Have any of you been waiting for real-world business examples of AI replacing the needs for experts while also increasing productivity by orders of magnitude and decreasing costs at a level that can be described as a deflationary pressure? For years, I've had customers ask for automated ways to detect and fix inefficient Power BI reports with slow-running queries that use a lot of compute. Fixing slow Power BI reports has historically been prohibitively time-consuming and required expensive talent. What if you could fix the problems with most slow and compute-intensive Power BI reports in a fraction of the time that it used to take, with nothing but Microsoft M365 Copilot? No fancy MCP servers, no additional software, no public repos. You can fix it with just Power BI Desktop and M365 Copilot. For this video, I'm going to show you how to use Copilot AI today to optimize slow Power BI semantic models and Power Query so that you can make reports run faster and also save a lot of money in compute costs, person hours, and sometimes consultant costs. The best part is that it's not on the roadmap or in a hypothetical hyped up future. And I'll say it again, all you need is Power BI Desktop and M365 Copilot. I'll walk you through how M365 Copilot can read the underlying code of your semantic models and the related Power Query scripts, find the inefficiencies, and create step-by-step expert consultant-grade instructions to fix it. At the end of the video, I'll review the dramatic improvements in performance that are achieved with minimal time investment, and then talk about my thoughts on the future of the analytical workforce and how it mirrors discussions from the big picture about a K-shaped economy. Now, when I say you can save a lot of money, I mean optimization tasks that used to take days or weeks will now take a few hours or less with a few clicks. In my live recorded video, I get a comprehensive report and step-by-step instructions to fix my Power BI report in less than 20 minutes. To be clear, this would have taken 16, 40, maybe more hours of time just a few years ago, which is thousands of dollars in person costs when you pay hundreds of dollars an hour for someone who knows what they're doing. Resources with deep expertise in dimensional data modeling, DAX expression language, Power Query M code for ETL, and AI optimization are not only expensive, but they are also in extreme scarcity. You'll only need to be at an intermediate Power BI skill level to implement the changes. For the record, I say that having spent several years of my own life trying to become a dimensional modeling and DAX expert. So it's a little bit of a punch in the gut for me to see this work as well as it does. When you hear about AI replacing the experts, this is an example of what it can do in the real world. This video is the first in a series I'm doing to show real-world, you-can-do-it-today examples of how AI can transform your existing data, reporting, and analytics ecosystem to save big money and reduce the duration of your human-powered work cycles by orders of magnitude. My name is Greg Beaumont, and I currently work for Microsoft, but the contents of this video are my own and do not necessarily represent the views of my employer. You can connect with me on LinkedIn. I have a blog to cover current and past topics intended to be educational for folks in the data community, and if you like this video, please give it a thumbs up and follow the channel. Let me start by saying that I've been along for the journey with Power BI since before it existed. I was building ProClarity dashboards and working with SQL Server 2005 cubes before Microsoft purchased ProClarity. At one point in my career, I spent a few years trying to become an expert at SQL Server Business Intelligence cubes and writing MDX. So how am I going to show you that this works? I started with a Power BI solution that I built a few years ago for a book that I wrote titled Power BI Machine Learning and OpenAI, which can still be purchased through Packet Publishing. The machine learning and OpenAI components of the book are outdated today, but the first 6 chapters can help you build a Power BI solution using real FAA wildlife strike data. The data from the FAA is great. It contains every reported incident of birds or other wildlife striking aircraft over the last 35 plus years. There were even a few pigs struck by airplanes, but they were all at a height of 0, confirming that despite the rise of AI, pigs still don't fly. I had a lot of fun taking my old report and making it terrible. I added bad ETL steps in Power Query, custom DAX columns in the semantic model. I wrote a lot of bad DAX runtime expressions. I added many-to-many relationships, got rid of the date dimension, and more. It was actually fun to make a report run slower and less efficient with some really bad code and architectural decisions that are not just bad, but commonplace in the real world. Now I'm going to show you how Microsoft 365 Copilot can read my worst practices PBIP file and then compare what it finds to the list of bad architectural patterns that I added to the solution. If I start with an ordinary report, it looks fine on the surface, nothing special, but let's take a look at the data model. Even at this level, you can probably see quite a few problems. There are many-to-many relationships. There is a duplicate table with the same key and a one-to-one relationship. There are bidirectional relationships. It doesn't look like any of the key columns are hidden, and you'll even see on the fact table that there are some columns which have both text and integer versions of the same value. You can see there's a calculated column too. If we look at some of the DAX expressions, there are some where divide does not use the DAX divide function, iterator functions with nested if statements, and other bad patterns for writing DAX expressions. After I use M365 Copilot to analyze everything, including the underlying Power Query layer, I'll show you a list of things I purposely built badly, how much of it was found by Copilot, and then also anything Copilot found that was just there from my work a couple years ago, but never should have been in the first place. So how does this work with only M365 Copilot and Power BI Desktop? The new Power BI Save As file type is PBIP, which breaks up the different Power BI components of Power Query, the semantic model, and the reports into different file parts. You can see that the structural components of the semantic model and Power Query are TMDL files. Copilot cannot read that file type, but if I open the files as text files, suddenly they are readable. You can see the fact table contains all the DAX expressions, including this eyesore, which has a SUMX with nested if statements, and all metadata for the columns. Within these TMDL files is all the information you need to understand the architecture of the entire Power BI solution end to end, from the ETL to the actual report page. First, I created a clean folder in OneDrive. Then I copied the TMDL files for model, relationships, and expressions to that file. Next, I copied over all the table files. You can even see the auto datetime intelligence tables with the long GUIDs in the titles. Finally, I changed the extension name of the copied files to .txt, which makes them readable by Copilot. Another good reason to use Copilot for this task is when you're using Copilot, it keeps all of your data within your tenant, so that if there's any sensitive data in these files, it's not getting outside of your security boundary. You can then copy a link to the folder containing those files. I have a carefully written prompt designed to instruct Copilot what is to be assessed from the files, including subject matter, data architecture, query design, and prepping everything for AI. You can find a copy of the prompt at my blog, which is linked in the video description. I add the URL for the OneDrive folder to the prompt. You'll see I'm just using the M365 Copilot Researcher agent set to auto for model selection. Then I hit go and answer a few short questions. Hit go again, and about 15 minutes later, I have an expert level report assessing the solution. Walking through this report, you'll see how robust and detailed the assessment is. An assessment to this level of detail would have cost thousands of dollars in consulting fees just a few years ago. I'll also make this report accessible from my blog so you can review it for yourself. And I'll go ahead and convert this to a Word document. But how does a non-expert make an action plan out of this assessment? I have another prompt also available on my blog to use the contents of the files and the previous report to put together a step-by-step plan for fixing all the issues. I run that prompt, and a few more minutes later, I've got my paint-by-numbers plan to fix the Power BI report. Again, the report can be accessed from my blog if you want to check it out. I don't walk through all the steps, but I'll show a few examples. The instructions called out duplicate and unused tables. Recommendations were made for integer values versus text. Recommendations for one-to-many single-direction relationships were also made. Changing key values to integers were recommended for a few tables. Key values were hidden. Unnecessary columns were removed. I was advised to add a date table instead of using auto datetime intelligence. ETL steps in Power Query were consolidated. A bad DAX runtime expression containing an iterator SUMX function with nested if statements was fixed. For that one, the code it gave me wasn't quite right, but I was able to quickly fix it with another M365 Copilot question. I moved the iterator logic back to Power Query and then used a simple sum on the front end. There were other bad DAX expressions that were also fixed. It even found one that I errantly built in the first place using a filter statement within a calculate function, which wasn't necessary. There's another example where it instructed me to take a concatenated column and push it back to Power Query. Calculations were also moved to a folder where they are easier to find, and then the implicit measures are discouraged, which makes everything more AI friendly. Naming conventions were also modified to be more AI friendly, and unimportant columns were hidden to prep for AI. I also created another M365 Copilot prompt to create the AI instructions for the model, but I decided to leave that one for a future video. Now the big question, what were the results? I did some testing on the Power BI desktop files, old and new, and I saw a 45% reduction in refresh times. The PBIP file was reduced from 24 to 5 megabytes in size. That's a 79% reduction. I do think that removing a few free text columns from the model that weren't being used was the reason most of that improvement happened, but the improvement was all due to M365 Copilot's recommendations. I ran several sequences of unit testing report usage, and Power BI Performance Analyzer recorded an overall reduction of 25% in rendering speeds. And the time invested to make this happen, 20 minutes with M365 Copilot Researcher to generate an assessment and a step-by-step paint-by-numbers plan to make the improvements. Then about another 2 hours to implement the changes. With a large Power BI solution, you could be looking at reducing the effort from thousands of dollars, which could even be a conservative estimate given the quality of the report, to a few hours. No new tools, no MCP servers, nothing needed but M365 Copilot and Power BI Desktop. So what did it miss? Copilot could have done better addressing some of the degenerate dimensions on the fact table, such as aircraft manufacturer and aircraft dimension. Those potentially could have been split off as a separate dimension. But that being said, it might make those recommendations if I were to include some sample data in a future iteration of this approach. It left a few text keys where adding a surrogate integer key might make sense. No recommendations were made on data types such as geography, but those are mostly small things, and it caught the big performance bottlenecks. I'm sure there's other things it missed, but overall the results were impressive. If you so desire, you could even take the new PBIP file and run it through Copilot again to see if it picks up new issues after you've made the improvements. Rinse, wash, repeat. In my opinion, this is the promise of AI brought to reality with measurable results that will speed up time to delivery, reduce your dependency on experts and consultants, reduce the number of service tickets you need to open, reduce the compute you need to run your reports, increase the speed at which your reports run, and also decrease your total cost of operation at a level I would almost call deflationary. Documentation, including all the prompts, can be found in my blog article, which is linked in the video description. As a capstone to this video, what does this mean to the future of the analytics workforce? Here's my completely speculative perspective. Today, you've got thought leaders and innovators who create new technologies and write the standards that everyone follows. Think of the people designing new databases and query technologies, or the experts who write the books that define the standards. These people work on the bleeding edge and don't usually engage to fix real-world implementations. Then you've got the subject matter experts who work as expensive consultants, as experts at big tech companies. These are the people who memorize and understand at a deep level the content created by the thought leaders and innovators. They infrequently innovate, but are experts at teaching and interpreting content from thought leaders. These people are hard to find, very busy, and can be very expensive. Next up is implementation engineering leaders who work as lead architects, solution designers, and team leaders to take the technology and apply it to real-world use cases. Finally, the implementation workers who build things to spec from the implementation engineering leaders. What might AI mean for this diagram? Top subject experts won't be needed anymore. Thought leaders and innovators will be able to scale their influence using AI, and the implementation engineering leaders will be able to get the answers they need without opening tickets or hiring expensive unicorn consultants. Implementation engineering leaders will also be able to take on more projects and scale using AI, and the projects will progress more quickly. There might be a reduction in headcount at this level too. Finally, the implementation workers will also be able to work faster and leaner using AI, and some of their work will be automated. It looks a lot like the K-shaped economy that everyone hears about in the media, where the top 1% will thrive, the middle gets cut out, and the entry-level folks will need to embrace automation. Again, if you like this video, please let me know in the comments, give it a like, and follow the channel. Also, if you have suggestions for future topics related to this video, please pass them along. Thank you.